Two switches, one light, and either switch controls it. This is three-way switch wiring, and you are watching it work. Flip the switch at the bottom of the stairs. The light comes on. Walk up, flip the other one off. No smart bulbs, no timers. Just two clever switches and 3 wires between them. Stay with me for 9 minutes, and you will understand three-way switch wiring step by step. The terminals, the travelers, the 4 switch states, and the mistakes that catch almost everyone. Let us start with the name. First, the name. A three-way switch is not called that because there are 3 switches. There are only 2. It is called three-way because it has 3 terminals. One terminal is the common. Think of it as the switch's front door. Electricity always enters or leaves through that one point. The other 2 are traveler terminals. Inside, the switch connects the common to one traveler or the other. Never both. Never neither. So a normal switch says on or off. A three-way switch only ever says path 1 or path 2. Hold on to that. It is the whole trick. Put 2 of them back to back, and you can control one light from 2 different places. Quick pause. The exact diagram from this video is free to open in your browser at CircuitDiagramMaker app. No install, no sign up. The link is in the description. Open it and follow along. Right back to the wiring. Now, the actual wiring from the panel to the light. Power leaves the panel on the hot wire and lands on the common terminal of the first switch. That is the front door. From the first switch, 2 traveler wires run side by side to the second switch. Traveler to traveler, straight across, and only one of them is ever live. At the far end, the second switch's common terminal carries power onward to the light, through the bulb, then back to the panel on the neutral wire, completing the circuit. Notice the neutral never passes through either switch. It runs straight home. In a typical installation, the travelers ride together in the same run between the switch boxes. That is why 3-conductor cable exists, 2 travelers plus 1 more wire, in a single jacket. So the chain is short. Hot into common 1. Travelers across. Common 2 out to the light. Neutral back. And here's the rule that makes everything click. The light is on only when both switches point at the same traveler. If switch 1 feeds the top traveler while switch 2 listens on the bottom, the path is broken. They have to agree. Let us walk all 4 combinations, one flip at a time. State 1. Both switches point at the top traveler. The path is complete, current flows, and the light is on. State 2. Flip switch 1 down. It now feeds the bottom traveler, but switch 2 is still listening on the top. Mismatch. The light is off. State 3. Flip switch 2 down as well. Both now point at the bottom traveler, so the path is complete again. On, through the other wire this time. State 4. Flip switch 1 back up. Mismatch again. Off. See the pattern? Every single flip, at either switch, turns matched into mismatched, or mismatched into matched. That is why either switch always toggles the light. Neither one is the master. The pair either agree, or they do not. Matched travelers, light on. Mismatched, light off. That is the entire theory in 2 sentences. And it is why these pairs live at staircases, hallways, and garages. Anywhere walking back to the first switch would be annoying. One aside before we move on. If you ever need control from 3 places, a 4-way switch drops in between these 2 and crosses the travelers. Same idea, one more box. That is a video of its own. On a real switch, the 3 terminals are marked, but subtly. The common is the odd one out. On most switches, it is a darker screw, black or copper-colored, while the 2 traveler screws are shiny brass. Some brands stamp the word common into the plastic on the back instead. Here's the catch, though. The common is not always in the same corner. One manufacturer puts it bottom left, another puts it opposite. So never wire by position. Find the dark screw or find the label. And if you're looking at an existing installation, the wire on the dark screw is your common. Note it before anything comes apart. 30 seconds of checking beats an hour of head-scratching later. Which brings us to the classic mistakes. Mistake 1. A traveler wire landed on the common terminal. Swap those 2, and you create the most confusing fault in home wiring. The light works from one switch, but only sometimes from the other. If a 3-way circuit half works, check both commons first. Mistake 2. Treating a three-way like a normal switch. There is no on or off printed on it, and there cannot be. Up and down mean nothing on their own. Everything depends on the other switch. Mistake 3. Mixing up the travelers with hot or neutral. Travelers only ever run between the two switches. They never touch the light, and they never return to the panel. And a bonus tip: the moment you identify a common wire, mark it with a piece of tape. Future you, staring into a crowded switch box, will be grateful. One quick note before the demo. This video explains the circuit and the diagram. For real installations, local electrical codes, and a qualified electrician apply. Now let us look at the real thing, live in a browser. This is the free editor at CircuitDiagramMaker.app with a built-in three-way switch template open. Nothing here is a sketch. Every wire is a real electrical connection the simulator understands. Look at the layout. The hot feed comes down from the source, through the breaker, into switch 1 at location A. The travelers cross to switch 2 at location B. Then the light and the neutral running home. Exactly the chain we just built. Notice the labels too. Location A, location B, hot, traveler, neutral. The template comes annotated, so the diagram reads like the explanation you just heard. And in the symbol library on the left, there is the three-way switch itself. One common pin, two traveler pins, sitting next to outlets, breakers, and light fixtures. You can drag these onto the canvas and build the whole thing from scratch if you want. But here's the part one love. It simulates. Hit Simulate in the toolbar, choose DC operating point, and run the analysis. The built-in solver reads the whole circuit, computes the real node voltages and currents, and overlays them straight onto the diagram. Look at the numbers. 120 volts on the live side. Half an amp flowing through the completed path. Down the hot, through switch 1, along the live traveler, through switch 2, and into the light. The live path is highlighted, so you can trace exactly which traveler is doing the work. And if the switches disagreed, that path would break and the light would read 0. The same 4 states from earlier, but now with real electrical numbers behind them. Change the load, and the numbers follow. Make the lamp a different wattage, run it again, and the current updates instantly. It is a sandbox with real physics. This is the fastest way I know to actually understand a circuit. Not staring at a picture, running it. So here's the whole story one more time. A three-way switch has 3 terminals. One common, the front door, and 2 travelers. Power arrives at the first common, crosses on the travelers, and leaves the second common for the light. The neutral runs straight home. Matched travelers, light on. Mismatched off. And every flip at either switch swaps one for the other. Want it to really stick? Open the same three-way switch template free in your browser, run the simulation, and rewire it until you can predict every number. The link is in the description. No install, no credit card. Subscribe for a new wiring diagram explained every week. See you in the next one.